What if a massive asteroid was heading toward us? 66 million years ago, the Chicxulub asteroid hit the Earth and wiped out dinosaurs, as well as much of the rest of life on the planet. It measured 50.3 miles in diameter. Its impact generated a force equivalent to the simultaneous detonation of 100 million SAR bombas, the most powerful nuclear device ever detonated. While the dinosaurs had no way of defending themselves then, surely by now we have come up with ways to avoid their fate. Sadly, the answer to that isn't as straightforward as a yes or a no, but one thing is for sure, we're trying. While NASA has been honing its technologies for detecting incoming asteroid impact events, they aren't perfect yet. In 2013, a tiny meteor measuring just 65 feet in diameter blew apart over the city of Chelyabinsk, Russia, without warning. Despite its diminutive size, the event injured 1,500 people and caused up to $30 million in damages. Currently, we rely on telescopes to detect any asteroids that may be coming our way. The data from the telescopes is scanned. Image differencing software is used to check if there are any moving objects, and it calculates their trajectories. If necessary, more powerful telescopes are then used to obtain a better view of any object that is at risk of hitting the Earth. Detection is definitely the first thing we have to nail if we're to have any faith in our ability to protect ourselves from an asteroid impact. To better organize efforts toward containing this hypothetical threat, NASA established the Planetary Defense Coordination Office in 2016. There couldn't be a better organization to spearhead this either, as 95% of all near-Earth object discoveries have been attributed to NASA-sponsored surveys. Since 2015, about 1,500 new near-Earth objects have been discovered each year, and about 25,000 of those previously documented are at least 460 feet in size. As part of their efforts, NASA's Ames Research Center is also utilizing supercomputer simulations to aid in predicting the effects of potential asteroid impacts. This data, aside from data regarding the asteroids themselves, is invaluable in letting us perform risk assessment and management on the ground. We can prepare for smaller impact events, sure, but what about asteroids approaching the size of the Chicxulub asteroid? Can we prevent them from hitting the Earth with a cosmic haymaker? Asteroid impact avoidance is the formal term used for our currently theoretical methods of protecting the Earth from an asteroid impact. Surprisingly, the only way to do this is to blow the asteroid up. Scientists believe that by detonating a nuclear device on the surface of an oncoming asteroid, the ensuing force could be enough to divert an asteroid's trajectory from hitting the Earth. So how does it work? Newton's third law. When two bodies interact, they apply an amount of force to each other, which is equal in magnitude and opposite in direction. By fragmenting the asteroid, debris or ejecta will be propelled in one direction, with the rest of the asteroid in another. This is the same principle behind an alternative method of diverting an asteroid's path, utilizing a kinetic impact. In basic terms, it involves hitting an oncoming asteroid with a big enough object and with enough force to change its path. The research craft Deep Impact has already shown that this could theoretically work to divert an asteroid. It was able to successfully intercept Comet Tempel 1 in 2005 to gather data about the comet's composition. This is definitely encouraging for the future. One last method scientists are proposing is still mostly theoretical: the gravity tractor. Scientists propose that by using the gravity from a large uncrewed spacecraft, they will be able to gradually pull an asteroid into a non-threatening orbit. By having this spacecraft orbit the asteroid at a consistent speed, scientists believe that the gravitational force generated by the spacecraft will be enough to influence the asteroid's path. Another benefit of utilizing a gravity tractor is little or no data regarding the asteroid's composition or spin rate is required. Blowing up an asteroid or hitting it with a spacecraft may seem straightforward, but scientists would need a large amount of data to prepare the necessary materials and impact site. A gravity tractor will only require the asteroid's coordinates. Unfortunately, this method is not only expensive, but also extremely time-consuming. Scientists speculate that meaningfully changing an asteroid's trajectory using a gravity tractor would take anywhere from a few years to a few decades. This is time we simply may not have with our current technology. Still, there's a lot to appreciate about the inroads we've made toward preventing an impact event from destroying life on Earth as we know it. If science and technology will one day enable us to fend off cosmic threats, who knows what else we will be able to accomplish.